inverse functions. So if we have two functions, say f of x and g of x, those two functions are inverses of each other if f of g of x is equal to x and g of f of x is equal to x. Alright, so you may also see this written as, you may see f of g of x like that, and g of f of x. That's called composite functions or composition of functions. So when you find the composition of the two functions by saying f of g of x and g of f of x, and it just equals x, it's not that they equal the same thing, it's that they both equal x to the first power, then the two functions are inverses of each other. So if I wanted to know, say, are the functions inverses, and I had f of x equals 5x plus 1, and g of x equals x minus 1 over 5. Are the functions inverses? Well, to find out, you say f of g of x, which means take the g and plug it into the f where there's an x. So it'd be 5 times x minus 1 over 5 plus 1. You see, I took this and I plugged it into x. So let's see. The 5's cancel out. X minus 1 plus 1. That's just equal to x. So we're halfway there. If g of f of x is equal to x, they're inverses. So take the second and plug into the first. So I'm going to take this right here, and I'm going to plug it in right there. So 5x plus 1 minus 1 over 5. The 1's cancel out. 5x over 5. That's x. So since f of g of x equals x and g of f of x equals x, they're inverses of each other. Okay? What about this quick example? Same concept. F of x equals natural log of x. G of x equals e to the x. So f of g of x would be the natural log of e to the x. So take this, plug it in right there. We learned that the natural log of e to the x, remember that's log base e of e, that's just equal to x. And if I work it out the other way, take the f, plug it into the g. So that's going to be e to the natural log of x power. So that's log base, or that's e to the log base e of x. That's just equal to x. So natural log and e to the x are inverse functions. That's a big find there. That's awesome. Okay? But how do I find the inverse of a function? Finding the inverse of a function takes 4 steps. The third step is usually the longest. So say I wanted to find the inverse of f of x equals 2x plus 3. The first step is to make the equation y equals. Instead of f of x, we start off just using y. The second step is to interchange x and y. Interchange x and y. That means where you have an x, write a y, and where you have a y, write a x. That doesn't mean switch around terms yet. That just means every x you write a y, for every y you write an x. So x equals 2y plus 3. Now the third step, the one that's usually the most complicated, solve for y. Step 3 is solve for y. So if I move these terms around, I could have 2y equals x minus 3, and I've solved for y. Once you have y by itself, step 4, you have found the inverse. So you can write f with a little -1 there. That means f inverse. That's f inverse of x is this. You just replace the y with this symbol. X minus 3 over 2. All over 2. So that is the inverse. 4 steps every time. So you say, well, what could make this complicated? Well, what if my function is x squared plus 2x minus 5, and I want to find the inverse? So I have x equals y squared plus 2y minus 5. How do I solve for y? Because if I tried to factor a y, even if I moved the 5 over and tried to factor a y out, I'd still have a y in both factors. That may be something that y'all might want to think about. There's no calculus involved in that. That's just algebra. And so that may be something that you may want to just tinker with if you have any spare time one day.